A pole shift on the sun is imminent. The magnetic field of our star is reversing, and this will not leave us on Earth unscathed. What exactly is in store for us, and could it even be dangerous? We'll find out in this video, so make sure you stay tuned until the end. If you like it, I'd be galactically happy to receive a thumbs up and a comment, because that's how we get the algorithm to show this exciting topic to even more people. Thank you guys and welcome. The sun, a source of light and heat, without which not only would we not be here, but the entire planet would be a dull and dead rock. Our life-giving star, the source of our existence. And the source of sunburn and skin cancer, but you can't have everything. But the sun is much more than just that. It is a complex and dynamic astronomical object, perhaps the most complex system in the entire solar system. Take a look at this time-lapse image of the sun taken by NASA's Solar Dynamics Observatory over 5 years. It is immediately clear that there is a lot going on the sun. Plasma arcs, protuberances that are hurled into space, convection cells on the surface. And the most interesting solar feature is its magnetic field. As on Earth, it is created by processes inside the sun, but the details of these processes differ greatly from those on Earth. The sun's magnetic field is created by the process of magnetohydrodynamics, which in turn is based on the movements of charged particles in the interior. The sun consists mainly of ionized gas, also known as plasma, with hydrogen and helium making up the majority. Extremely high temperatures and immensely high pressure prevail in its core, which enables the hydrogen atoms to fuse together and form helium. This nuclear fusion process releases enormous amounts of energy that make the sun shine. This is also known as the proton-proton reaction. I hope none of you are having traumatic flashbacks to your physics lessons. The movement of the hot plasma inside the sun generates electrical currents, which in turn generate the magnetic field. This so-called solar dynamo creates the solar magnetic field that stretches from the surface of the sun far, far into interplanetary space. Here you can see an animation of the solar magnetic field, and we can see that it's already pretty busy. And in fact, many details about the sun's magnetic field are not yet known. NASA astrophysicist Holly Gilbert says, "We don't know exactly where in the sun the magnetic field originates. It could be near the surface of the sun or deep inside the sun or at a wide range of depths. Other things are now fairly well understood, such as how sunspots form, darker, cooler areas on the surface of the sun. These spots are the visible sign of the sun's magnetic field in action, so to speak, as they occur when the sun's magnetic field lines break through the surface and restrict the plasma flows, causing cooling and darkening in these very areas. The normal surface temperature of the sun is between 5000 and 6000 degrees Celsius. Within the sunspots, it is only a pleasant 3000 to 4000 degrees centigrade. So anyone traveling there should definitely pack a thick winter jacket. Well, now we know the basics about the solar magnetic field, and now the shocking news. This solar magnetic field is reversing. And sunspots are the key to understanding this. We have already learned that these spots are places with increased magnetic activity. And the reversal of the sun's magnetic poles is closely linked to the 11-year sunspot cycle. During this cycle, the sun experiences phases of increasing and decreasing activity. At the beginning of the cycle, known as the sunspot maximum, sunspots appear more frequently on the surface of the sun. It's a bit like puberty during the hormone peak, when there were always a lot of pimples on the face. And of course you always had the biggest pimples when you bumped into your crush. How embarrassing. That can lead to an emotional breakdown in 14-year-olds. Some of you will now say,
"Tim, stop talking about puberty and pimples."
Alright, but the comparison fits perfectly, because the sun also experiences a breakdown if there are too many spots, sunspots. This is because during the sunspot maximum, the sun's magnetic field reaches a point at which it becomes unstable. The sun's magnetic field is not rigid, but dynamic and can change over time. During this phase, the poles of the sun's magnetic field become increasingly weaker until they finally reverse their polarity. This means that the north pole of the sun becomes the magnetic south pole and vice versa. A solar pole shift. An event that also occurs on Earth, by the way. And the next Irish pole shift seems to be in the not too distant future. The whole thing can be predicted a little better on the sun, as it fits into the 11-year cycle already mentioned. Or, if you think about it, it actually becomes a 22-year cycle. Astrophysicist Mike Murray describes it like this. The 11-year sunspot cycle is only half of a full magnetic cycle because the sun's magnetic poles reverse polarity every 11 years. This means that the sun's north and south magnetic poles swap places. Then it takes about another 11 years for the sun's north and south poles to reverse again. So we can call this entire process the 22-year solar magnetic cycle. And this raises the not insignificant question, when will the next reversal happen? Answer, very, very soon. The sun's magnetic field will reverse its polarity at the peak of the solar activity cycle, which is currently predicted for late 2024 or early 2025. So, maybe next Christmas the solar pole shift will already be under the Christmas tree. How is it supposed to be under the Christmas tree? Doesn't make sense again. In any case, the time will soon come, and the exciting question is whether this could be dangerous for us and what exactly will happen. Firstly, it is important to understand that this is not an instantaneous thing and does not happen everywhere at the same time. In the last solar cycle, for example, the polarity of the northern hemisphere of the sun began to reverse at the beginning of June 2012 and then fluctuated around the neutral point until it stabilized again at the end of 2014. Although the southern center transitioned smoothly to the opposite polarity in 2013. This time, however, the poles seem to be switching more evenly. And there are three main effects on Earth: increased solar activity, protection from cosmic rays, and scientific knowledge. Let's go through these together. During the process of reversing the sun's magnetic field, it is very likely that the sun will experience an increase in strong sunspots, flares, and coronal mass ejections. All these events ensure that more high-energy radiation, also known as solar wind, is ejected into space, also towards Earth. And this can have an impact on communication systems, satellites, and the power grid on our planet. But at the moment there is not much to suggest that it will be more intense than average, but it may lead to us seeing more auroras, which are caused by the interaction between the solar wind and the Earth's atmosphere. I'll be back in Tromsø in Norway next week to go aurora hunting. I'll keep you up to date, of course. Here's a photo from last year, so as far as I'm concerned the sun can really step on the gas now. The next point is also a positive one: the protection against cosmic rays during the reversal of the sun's magnetic field, the so-called solar current sheet, is becoming wavier. The sun's current sheet is a region in space where the sun's magnetic field takes on a wavy structure and forms a better barrier against galactic cosmic rays. And this region extends far into space. This current sheet forms a perfect barrier against interstellar, galactic cosmic rays, high-energy particles from space that can also endanger satellites and affect the health of astronauts in space. During the reversal of the magnetic field, this protection is strengthened because the current sheet becomes more wavy and thus better shields the dangerous cosmic rays. Perfect, I would say. And it gets even better, because the solar pole shift is an absolute dream for scientists, as studying the reversal of the sun's magnetic field naturally provides valuable insights into the dynamics of the sun and other stars. And since it only happens every few years, for astronomers it's a bit like Christmas, New Year's Eve, and Monopoly at McDonald's all rolled into one. So more auroras, better protection against cosmic dangers, and unique scientific findings. I'd say a thank you is due. Why don't you all write in the comments, "Thank you, sun"? It's the least we can do to show our appreciation. And speaking of thanks, thank you for your galactic support. We're already well on our way to 20,000 subscribers, and that wouldn't be possible without you. Thank you guys so much for your amazing galactic support. The Earth is a victim of cosmic circumstances, as we can see from the magnetic field alone, which is constantly interacting with the solar wind. And many of the things we perceive as commonplace are caused by larger processes. These include ocean currents and the prevailing winds on our planet. According to a new, alarming study, the Gulf Stream could collapse as early as 2025, which would probably lead to a small ice age in Europe. How high is the danger really, and should we start buying thick winter jackets? You can find out in the video below, where I also show you spectacular visualizations of ocean currents. So click on it, and if you want to support my work, buy some great plush planets and real meteorites in the Astro Shop. Otherwise, I'd say see you in the next video. Take care, guys.